slideshow. Oops, got to enable editing from the. Okay. So we'll start with the characteristics, and this is just a review of everything we did. All right, for you guys that are here Friday, for guys that are home Monday. All right. So that's everything you can fill in. The domain is all 0 to infinity or x greater than 0. The range is negative infinity to infinity. The intercept's at 1, 0. Increasing on 0 to infinity. Y-axis is the vertical asymptote, and the reflection of the graph of x equals a of x in the line y equals x. All real numbers. It's the same thing. It's the same thing as running it. All right. Yes, ma'am. Okay. All right. Everybody good? Okay. So we'll start with transformations. Log a of x minus n, meaning parentheses, a transformation n units to the right. When it's plus n, it's n units to the left. Log a of x plus n, no parentheses, the transformation n units up. When n is negative, it's n units down. All right. Yo. All right. And then f of x equals negative log a of x reflected over the x-axis. Log a of negative x reflected over the y-axis. So negative outside, all right, flips it beneath, all right, and negative on the inside flips it to the left. All right. But now we introduce today's note, which is the natural logarithmic function, the function given by f of x equals log e of x equals natural log of x. It's called the natural logarithmic function. Oh, that's right. You have it? All right. It's called the natural logarithmic function. For x greater than 0, y equals 1, natural log of x, if and only if x equals e to the x. Did I not get you? My bad. You do it on first. Got it? Everybody got it? All right. natural log of x and e to the x are inverses of each other? We already did that, right? Already filled that in, so they're inverses of each other. All right, to evaluate it, you're just going to use a different button. All right, to evaluate it, you're just going to use a different button. So, all right, let's say you have to get the natural log of 15. The natural log, and figure it out in your calculator, is just whatever says ln. That's the natural log. All right, just hit that. 15. And it'll shoot out the decimal for you. It's just a different base. It's the log of base A. All right? And just like with logs from yesterday or Friday, we can't find the natural log of a negative number. All right? So you're just using a different button. All right? All good? Okay, so some property. That will help you simplify. The natural log of 1 is 0. The natural log of e is 1. The natural log of e to the x equals x. And if the natural log of x equals the natural log of y, all right, then x equals 1. All right. And again, that will come in handy when we deal, well, the natural log of 1 comes in handy. When we're graphing, so does the natural log of e, but we'll handle that in a second. All right, so determining the domain, take whatever we're finding the natural log of and set it greater than 0 since we can't find the log of a negative number. So for example, the natural log of x minus 2. X minus 2 is greater than 0. X is greater than 2 is your domain. And then, of course, from yesterday and Friday, x equals 2 is your asymptote. All right, natural log of 2 minus x. 2 minus x is greater than 0. Negative x is greater than negative 2. And don't forget, when we divide by a negative, we flip our sign, so x is less than 2. So that's your domain, and like we said, x equals 2 is still your asymptote. Now, when you look at x squared greater than 0. When we square a negative number, all right, it's a positive. So the domain is x not equal to 0. All right. Okay, the word problem we will talk about tomorrow during that half day. Right now, I want to go over graphing, so you're good to go with tonight's homework. All right. Okay, so it's going to be just like logs, just with different bases. So we got f of x equals the natural log of x. All right. When you pick your domain, all right. So recall when we graphed e to the x. Recall when we graphed e to the x. Negative 1, 0, and 1 gave us 0.4, 1, and 2.7. All right. It's just like regular logs, we're going to flip the x and y. So the 0.4, 1, and 2.7 become our x's. Negative 1, 0, and 1 become our y. All right. So negative 4, 1, 2.7 are my x's. Negative 1, 0, and 1 are my y's. When I graph them, this is a negative. This is 0.4, by the way. Not a negative, it's a 0.4. 0.4. So 0.4 is about halfway, negative 1, 1, 0. 2.71 is close to 3. There you go. All right. General shape of our curve. The domain, x is greater than 0, range all real numbers. X-intercept is given to us, 1, 0, so we can throw it down. X equals 0 is our asymptote. And f of x increases, all right, as x approaches infinity. All right. When I do f of x equals the natural log of x plus 5. All right. The plus 5, remember, there's no parentheses. So these values remain the same, 0.4, 1, and 2.7. The difference is, recall, I'm adding 5 to the y's because there's no parentheses. So the negative 1 becomes 4. The 0 from the original becomes 5. And the 1 becomes 6. So 0.4 and 4. About up there. 1 and 5. About there. 2.7 and 6. About there. Other than that, the graph remains the same. So since there were no parentheses, x is greater than 0. The range is all real numbers. The x-intercept, omit the asymptote, just replace the inequality with 0. And since it's still going up, it is increasing. All right. Number 3 now has parentheses, so that does impact the x's. In an opposite fashion. The opposite of plus 5 is negative 5, so we're going to subtract 5 from all those. We got negative 4.6, negative 4. All right. And then negative 2.3. Since there's nothing being added outside, we go back to negative 1, 0, and 1. Negative 4, because I'm going to take 0.4, I'm going to do the opposite of that to it. So 0.4 minus 5 is negative 4.6. 1 minus 5 is negative 4. Well, So negative 4.6, 1, 2, 3, 4. 0.6 is about there. Negative 1, negative 4, 0, negative 2.3, 1, 2, 0.3, and 1. All right. Whatever the opposite of that is also affects your domain and your asymptote. All right. So your domain, x is greater than still, but now it's negative 5. Your range is all real numbers. X-intercept, negative 4, 0. The asymptote, x equals negative 5, and we're still increasing. All right. Everybody good? All right. Number 4, f of x equals the natural log of negative x plus 2. All right. Ladies and gentlemen, because the only thing inside is negative, we're going to just switch our sign. So 0.4 becomes negative 0.4. 1 becomes negative 1. And 2.7 becomes negative 2.7. The plus 2 impacts our y. All right, the plus 2 impacts our y. So what was normally negative 1, 0, 1 becomes 1, 2, and 3. Negative 0.4 and 1 is about there. Negative 1, 2 is about there. And negative 2.73 is about there. All right, there's no number being added or subtracted, so our asymptote is still at x equals 0. The difference is all the numbers are to the left. This is what we just talked about in the note. So the domain, instead of greater than, is now less than 0. The range is all real numbers. Take a gander, see if you see your x-intercept real quick, which you don't, so you can skip it. And instead of increasing, f of x is now decreasing. All right. So when it's just negative x on the inside, flip your signs. Now 5, f of x equals the negative natural log of x plus 2. The opposite of plus 2 inside parentheses is negative 2. So I'm going to do that to my 0.4, my 1, and my 2.7. I'm going to subtract 2. I'm going to have negative 1.6, negative 1, and 0.7. When I plug in 1.6, it goes back to being 0.4. The natural log of 0.4 is negative 1, but the negative on the outside turns that into 1. When I plug in negative 1, that becomes 1. 0, the negative of 0 is still 0. When I plug in 0.7, I got 2.7. Natural log of 2.7 is 1, but the negative turns it into negative 1. Negative 1.61. Negative 1, 0. (0.7, negative 1). The opposite of plus 2 is negative 2. So the asymptote at x equals negative 2. Which tells me my graph is going to go like that because it can't cross it. Everything's to the right of it, so x is greater than 2 is my domain. My range is all real numbers. My x-intercept is one of my table values, -1, 0. And instead of going up, it is going down, so it is decreasing. All right. So then the very last one, f of x equals 4 natural log of 3x minus 1 plus 1. All right. You take whatever's inside parentheses and you set it to our three values. 3x plus 1 equals 0.4. 3x plus 1 equals 1. 3x plus 1 equals 2.7. So you take whatever's inside parentheses, it's a -1, not a +1. I'm sorry. All right. Now, because we're dealing with decimals and we're dividing, we may have to approximate. What I mean by that is this. If I add 1, I get 1.4. When I divide 1.4 by 3, I get 0.46 repeating. 6. All right? So you may have to write it 0.47. That's fine. All right? When I add 1, I got 2. 2 divided by 3 is 0.6 repeating. 3x minus 1 is 2.7. Add 1, 3.7. Divide by 3. I believe you end up with 1.23 with the 3 repeating. So 1.23. You just have to remember when you plug that back in, what happens. So in other words, this one's going to become 0.4. 4 times the net, 4 times 0.4 is 1.6. 1.6 plus 1 is 2.6. But again, if you get that number right, all right, if you get that number right, you can get away with plugging it in. This is what I mean. So 3 times 0.47 minus 1 brings you back to 0.41. And if you do the natural log 0.41, you get -0.891589811193, which is very close to the -1. All right. And if you do the whole thing in the calculator, 4 natural log of 3 times 0.47 minus 1 plus 1, again, you get the -2. All right, 6, that's on the outside. When I plug in 2/3, all right, this becomes 1. The natural log of 1 is 0. 4 times 0 is still 0, but 0 plus 1 is 1. When I plug in the 1.23, all right, this goes back to being 2.7. The natural log of 2.7 is 1. 4 times 1 is 4. 4 plus 1 is 5. There we go. Sorry about that. When I plot them, 0.47 negative 2.6 is about there. 0.61, about there. 1.235 is there. And it just stretches it out a little bit. To get the domain, the exercise we worked on before, we said 3x minus 1 greater than 0. When we solve it, x is greater than 1/3. The domain, x is greater than 1/3. The asymptote, x equals 1/3. Range is all real numbers. Look to see if you have your x-intercept, which you do not, so you can omit it. All right, and it's going up since that's positive, so that is increased. Okay. If any of you need the homework that's due tonight, that's up in Google Classroom, right there. Yes, so if you already got it yesterday, you are good to go. All right, if not, there's that, and that's due tonight. And then this one is due tomorrow. This is the new one. All right. Can you just wait a minute? I just want to say something real first. Those two. There you go. Now right there. This is nice. Okay. All right. So what I'm handing out is tonight's homework, what you probably grabbed over there as well. All right. So all right, give me a couple more minutes and then you're good to go. So this is tonight's, the one that's logged. All right, that's due tonight at midnight. This one, the one I just handed out and I posted today, natural logs is due tomorrow at midnight. Okay, so now you know your homework. Now, I just want to go over two things real quick so when they pop up, all right, and then you guys are good to veg out and people at home are good to veg out. Okay. Each week, there will be a new grade, type of grade popping up. It'll just say classwork and the dates. So for example, last week was February 1st to February 5th. All right. Each week will be out of 5 points. Each week will be out of 5 points. You have to do one thing. Show up. That's it. If you show up, put on your computer, walk away, walk your dog, have your breakfast, as long as your computer screen is on, you're good to go. So for each week, it'll be 5 out of 5. But if you took the quiz on Friday, that'll count. So if you show up and take your quiz, that'll count. So that'll be the new grade. So just so you know when that shows up. The second thing, homework. We are now almost a year into this, and I understand how hard this is on people. All right, homework. On time, 100%. 24 hours later, which means a day late, 50%. In between, there's a little bit of flexibility. So for example, if you submit a homework assignment at 2 a.m. instead of midnight, probably I'm going to put a 9.9 out of 10. If you submitted at 12:04, I'm not going to take points off. But if you submitted at like 2:33 in the morning, I'm just going to put a 9.9. It won't affect your grade, just so I know that you submitted a little late. If you submitted in the morning at like 7:30, it's probably going to be like a 9 or an 8.5. If you submitted at like high noon or 10 or 11, it's going to be like a 7.5. Okay, so it's kind of a sliding scale. But within 24 hours, it's 50%. All right, so if it's due at midnight on like tonight and you hand it in 11:30 tomorrow night, you'll get a 5 out of 10. After that, no credit. All right, so we're not doing submitting all the homework the last week of the marking period anymore. Not that that affects anybody in here. I'm not saying anybody. Up until now, you're fine. So if you submitted it up until today, I'm going to go back and check it out, and that's fair. All right? Now, listen to me and listen to me well. If you miss a quiz or test, all right, and again, this is moving forward, so this doesn't apply to last week. If you don't take it, you better be absent in Genesis. All right? So if you're sick, I get it. If you're doing something else, but we're moving past I'm going to take third period off to do something. All right. You're supposed to be in school during these hours. Now they're beginning all the testing and this and that to try and bring people back. I've heard. I don't know anything about that, but going back to 5 days a week. All right. But if you're on a hybrid day or you're a virtual student and you miss a quiz or test, I'm checking Genesis. All right. And if you're absent, you're fine. Same with this, the 5 points. If you're genuinely absent, I'm not going to penalize you. So when this happens, I'm going to go back and look and say, okay, are they present today? And if they're absent, it's fine. This is for people who are marked present but don't show up for the live stream. All right, just so you know. All right, sir, you can go to the bathroom. If anybody has any questions, you are fine. One more thing, but those of you playing the home game, if you want to split, feel free to go. I will talk to you tomorrow for the half day. Don't forget tomorrow's a half day. All right. So, Paige, when do you want to make up yesterday's quiz?
I can do it when I come home.
Today? Okay. So we'll set it up for 3 o'clock today.
Yeah.
All right?
I was like, oh, shoot, it should still be up. I was thinking 4th period, and then it's gone up.
Yeah. When that happens, if you are ever late, don't even if it's like up at the end, don't start, because chances are, like, I give people like a 15, 20-minute window, so it'll throw you out like in the middle of it.
Yeah, that's why.
Yeah, so just don't even start it. Yeah. So yeah, we'll open it up at 3 o'clock. I'll do it right now. We'll open it up at 3 o'clock for you. So you're good to go.
Mr. Strada, is the quiz in there for me to take during my fourth period?
Let me double check. Get you to remind me. 3A. Yes, it is. You want me to open it up now?
Yes, please.
Okay, I'll open it up. It should be open up right. Oh, I just opened it. If it's not open, come on back and we'll figure it out.
Okay, thank you.
You're welcome. All right, so there's that. All right, I can stop presenting and I can stop recording.